Welcome to PRISCI-ANTO Educational Academy. In this session, I am going to explain you the problem in two-dimensional random variable. The joint PDF probability density function of a random variable x comma y is given by f of x comma y is equal to e power minus of x plus y, comma 0 to x, limit of x is 0 to infinity, limit of y is 0 to infinity, or x and y are independent. Y. First answer is given, we have to take f of x comma y is equal to e power minus of x plus y. To prove x and y are independent, it's enough to prove f of x comma y is equal to f of x into f of y. First we have to find the probability density function of the probability density function of x is fx of x or f of x. This is the formula which is equal to integral f of x comma y into dy, f of x comma y into dy. So the limit is given 0 to infinity. 0 to infinity. What is f of x comma y? E power of minus of x plus y into dy, which is equal to integral over the limit 0 to infinity e power minus x into e power minus y. E power minus of x plus y can be written as e power minus x into e power minus y, which is equal to integral e power minus x into integral 0 to infinity e power minus y into dy. Now e power minus y into dy we can integrate. So therefore e power minus x, so fx of x, which is equal to f of x, which is equal to e power minus x. E power minus y, if you are integrating, e power minus y divided by minus 1, 0 to infinity, which is equal to e power minus x. Upper limit when you apply e power minus infinity divided by minus 1. When you apply for a lower limit y is equal to 0, e power 0 divided by minus 1. E power minus infinity, which is equal to 0. E power 0 is equal to 1. So therefore first term will vanish, will be 0. Second term will be 1. So e power minus x. This is f of x, which is equal to e power minus x. See, in the similar way you can find for the probability of density function y, f of y or f y of y, which is equal to f of y. The formula is integral f of x comma y into dx. Y means dx, x means dy, which is equal to integral over the limit 0 to infinity e power minus x into e power minus y into dx, which is equal to e power minus y integral 0 to infinity e power minus x into dx, which is equal to e power minus y e power minus x divided by minus 1. Limit is 0 to infinity, which is equal to e power minus y e power minus infinity minus e power 0 divided by minus 1. So first term will be 0, second term will be, which is equal to e power minus y, which one is f of y. So what is the independent? F of x comma y, which is equal to f of x, f of y. So this side, left hand side, is e power of minus of x plus y, which is equal to e power minus x into e power minus y, which is equal to e power of minus of x plus y. So both are equal, hence x and y are independent. X and y are independent.